Yellowstone National Park is home to more than 10,000 geysers, hot springs, and mud pots. It's also home to the largest supervolcano in North America, which last erupted some 640,000 years ago. While it is currently dormant, scientists are still monitoring it closely for any signs of life. In this episode of What If, we're going to find out how scientists are keeping track of the sleeping giant and what would happen if it woke up. When most people think of volcanoes, they picture a mountain that looks like Mount Fuji or Mount Vesuvius. But although these are stratovolcanoes, Yellowstone isn't. In fact, its official name is the Yellowstone Caldera because it's shaped like a cauldron, and that's due to its unique magma source. Instead of being located deep in the Earth's mantle beneath a mountain peak, the magma chamber at Yellowstone is just 6 miles beneath the surface. This makes it much more likely to cause a caldera-forming eruption, which occurs when the magma chamber gets so full that the land above it collapses. The last time this happened was 640,000 years ago. An eruption so large it emptied 2/3 of the magma chamber and covered parts of the modern-day US, Canada, and Mexico in ash. This made it one of the largest eruptions in history. But even though it's been quiet for hundreds of thousands of years, the U.S. Geological Survey now believes there's about a 1 in 730 chance of a major eruption in the next 200 years. That's around 1%, which might not seem like a big deal until you consider the potential consequences. So let's talk about that. If Yellowstone were to erupt tomorrow, the surrounding area would get completely obliterated. Ash would cover everything within a 200-mile radius. Most of the nearby towns would be uninhabitable for years, and tens of thousands of people would have to be evacuated from their homes. The economic impact would be colossal. The agriculture industry alone would suffer billions of dollars in losses, not to mention the effect on tourism. But those are just the local consequences. Because of how huge Yellowstone's magma chamber is, scientists think its eruption column would reach 30 miles into the air, injecting ash and gas high into the stratosphere. There's no telling how far the winds will carry this debris, but even small particles can stay suspended in the atmosphere for months or even years. This would disrupt global weather patterns and block out the sun. Some projections estimate that temperatures could drop by 2 degrees Celsius for several years, which would cause widespread crop failure and famine. There would be other environmental impacts too, such as acid rain caused by sulfur dioxide emissions. Needless to say, it would be pretty awful. But before we all retreat into our bunkers, let's look at why scientists are able to monitor it so closely and how accurate their predictions are. Yellowstone's magma chamber is 43 by 28 miles wide and sits 6 miles beneath the surface. As mentioned earlier, that's shallow enough to cause the ground above it to bulge, creating a caldera. The Yellowstone caldera is actually made up of 3 smaller calderas. The oldest is dated back 2 million years, and the newest is only 12,000 years old. You can see the fault lines created by these past eruptions by looking at the land around the park. This is known as radial faulting, and it happens because as magma accumulates beneath the surface, the land above it gets pushed upwards. But as the magma chamber empties during an eruption, the land has nowhere to go but down. The good news is that these fault lines give scientists a sort of roadmap for where the magma chamber lies. It also helps them tell how full the magma chamber is without even drilling into it. See, the more magma there is beneath the surface, the more the land is pushed upwards. Scientists have installed instruments called tiltmeters that detect these minute changes. They've also used GPS to measure the movement of various points across the caldera. These measurements allow them to create a map of what's happening beneath the surface. And so far, they've found nothing too alarming. But if there was something to be alarmed about, they'd need a way to measure it. Enter seismic monitoring. Just like earthquakes, volcanic eruptions are accompanied by seismic activity. The difference between the two is the type of waves produced. Earthquakes produce both P and S waves, while volcanic activity mostly produces only P waves. P waves are faster and less damaging than S waves, but they can still pose a risk if detected. That's why local residents are trained to take cover if they feel 2 earthquakes with only seconds in between them. That's because the first quake will always be a P wave, and the second one will be an S wave. But seismic monitoring doesn't just tell us about the strength of an eruption. It can also pinpoint exactly where the magma chamber is located. Each eruption at Yellowstone has left behind a network of magma conduits, or pipes, that magma can travel through. Seismic monitoring allows scientists to track the location of the magma as it travels through these pipes, and if it gets close enough to the surface, they can warn the public and start evacuation procedures. Finally, there are remote sensing tools that can detect changes in the heat signature of Yellowstone's various features. Hotspots or areas of intense geothermal activity can give scientists early warning signs of an eruption. In particular, they're looking for something called a lava lake. Most active volcanoes have these lava lakes near the summit. They form when magma rises up and pools in the upper conduit. It gives scientists an idea of how close the magma chamber is to overflowing. So, with all these monitoring systems in place, you might wonder if scientists have ever gotten close to predicting an eruption. Well, in 1985, they actually did. For the first time, researchers were able to observe an impending eruption of Mount Unzen in Japan. It started with a buildup of pressure, then minor seismic activity, followed by small steam explosions. But after 6 months, the magma chamber suddenly emptied and the volcano erupted. Scientists hadn't predicted the timing, but they had predicted it would erupt. And that same thing happened again in 1991. This time with Mount Pinatubo in the Philippines. Years of monitoring showed signs of unrest, and eventually, thousands of earthquakes were recorded daily. Unfortunately, the eruption caught many people off guard, but thanks to the monitoring, others were able to get out safely. However, it hasn't always gone so smoothly. Before 1980, there wasn't much seismic monitoring in the U.S., and Mount St. Helens blew up without any warning. It was the deadliest eruption in U.S. history. So even with all these monitoring tools, scientists are still playing catch-up. To learn more about what happened at Mount St. Helens, stay tuned. And now let's go back to Yellowstone. In recent years, there have been concerns that the Norris Geyser Basin could erupt. It shows signs of increased seismic activity and the magma chamber seems to be getting closer. But here's the thing. Even if the Norris Geyser Basin were to erupt, it wouldn't be a big deal. Sure, it would devastate the local ecosystem and probably kill the nearby wildlife, but it wouldn't cause the rest of the park to collapse. The only thing is, it's impossible to predict where these hydrothermal eruptions will occur. But thanks to seismic monitoring, scientists have been able to rule out some possibilities. The data shows that the magma chamber isn't located directly beneath the Norris Geyser Basin, meaning the chance of a massive eruption is low.